In this video, we're going to look at the sum and difference identities for sine, cosine, tangent. We're also going to look at cofunctions again and verify some identities. So here is how we define the sum and difference for cosine. If it's a cosine of two angles and I'm adding them together, it becomes the cosine of alpha cosine beta minus the sine alpha sine beta. And if there's a subtraction between the two angles, then it actually becomes a plus. It's cosine cosine sine sine with a plus. When we are looking at the sum and difference for sine, if it is a sine of two angles, sine of alpha plus beta, it's a sine of alpha cosine beta, cosine alpha cosine beta with a plus. So the sine has the same sign, the cosine is the opposite sign, and it's sine cosine cosine sine. So you notice that it is sine of alpha minus beta, is sine alpha cosine beta minus cosine alpha sine beta. The sum and difference for tangent is, to find the sum and difference for tangent of alpha and beta, you can just simply put the sine over cosine and then divide everything by cosine alpha cosine beta, and you will get this one. The same thing with the difference. If you would like to know how we got to these, you can look in your book on section 7.2. There are proofs for these for your viewing pleasure. We're going to spend the time, however, rather than proving this, to find exact values using the sum and difference. So if they're asking us to find exact values using the sum and difference, then what I'm going to do is I'm going to use the angles that I know that are on the unit circle. So I'm going to think about 15. There are multiple ways to get 15. One of the ways in which I can get 15 is I know that 30 minus 15 gives me 15, but 15 is not on the unit circle, so that's not a choice I would use. But I do know that 45 minus 30 gives me 15. So I can write the cosine of 15 degrees as the cosine of 45 degrees minus 30 degrees. This then allows me to use the cosine difference. So it is the cosine of 45 degrees multiplied by the cosine of 30 degrees, and it's the opposite sign. It's a subtraction of the angle, so I add here. The sine of 45 degrees, the sine of 30 degrees, and then I go get my unit circle and I look up the cosine of 45 degrees, which is the square root of 2 over 2. The cosine of 30 is a square root of 3 over 2, and then plus the sine of 45 is square root of 2 over 2, and the sine of 30 is 1/2. My final answer as an exact answer is going to be the square root of 6 plus the square root of 2, all over 4, because I have a denominator that's the same, so I can just add my numerators. The way that I'm going to approach the sine of 12 degrees, or excuse me, pi over 12, not 12 degrees, pi over 12, and it's a negative, is I'm going to think of this as the fact that sine is an odd function. So this is the same thing as the sine of pi over 12. Now what I want to do is I want to find two angles that add up or have a difference of pi over 12, and I'm going to use multiples in which the denominators will cancel down to 2, 4, 6, or 3, because I have exact values on my unit circles for that. So of course I can do 2 pi over 12 minus pi over 12, which, as before, the 30 minus 15 did not help me, even though pi over 12 reduces to pi over 6 on the unit circle. Pi over 12 is not. So I'm not going to use that one. What I am going to do, though, is how about 3 pi over 12 minus pi, or 2 pi over 12. That does give me a difference of pi over 12, and it also reduces to values that I know are on the unit circle, which is 3 will go into 3 ones, 3 will go into 12 4 times, and then minus the pi over 6. So I can write this as the negative sign of pi over 4 minus the pi over 6. This then gives me negative sine of pi over 4, and I'm going to just do it like this so I can have the negative out there and then distribute through in a minute. The cosine of pi over 6, and then the sine is the same, so if it's a subtraction of the angles that I subtract here. Now I deviate a little bit from the sine, cosine, cosine, sine. I actually do the sine again. This time I'm going to do pi over 6, and then the cosine of pi over 4. It doesn't matter, it's going to get the same answer, but it's just what I like to do. So negative, and then pi over 4, the sine of pi over 4 is a square root of 2 over 2. The cosine of pi over 6 is the same thing as 30 degrees, so it is going to be the square root of 3 over 2, minus the sine of pi over 6, which is 1/2, cosine of pi over 4, which is square root of 2 over 2. And then this is going to then know that it's going to be the negative of the square root of 6 minus the square root of 2 all over 4. Pulling that negative through, I get negative square root of 6 plus the square root of 2 over 4. And you're going to see these numbers a lot over and over again because we are using values on the unit circle. So you're going to see them a lot. Now let's take a look at 75. Again, I want to think about as adding or subtracting. It doesn't matter as long as it is angles that you're adding or subtracting that are on the unit circle. The easiest ones are going to be the cosine of here. We know that that 75 is the same thing as 45 plus 30. So this is going to be the cosine of 45 plus 30, which we know from up above is going to be the cosine of 45, the cosine of 30, and then since it's a plus, it'll be a minus here, so it is the sine of 45, the sine of 30. And these are all degrees. Don't forget my degree symbol. Those are all in degrees. And then I'm going to get the cosine of 45, which is a square root of 2 over 2. The cosine of 30, it's a square root of 3 over 2, minus the sine of 45, which is the square root of 2 over 2. The sine of 30 is 1/2. So I end up with the square root of 6 minus square root of 2 all over 4, and that's my answer there. Now I'm going to go ahead and do the tangent, and I need to think about angles that add up to 17. And those angles add up to 17 pi over 12 are going to reduce in such a way that I am going to get angles that are on the unit circle. If I try to say, okay, 17 pi over 12 is equal to 5 pi over 12 plus 12 pi over 12, well, that's all cool for this one. This one is not on the unit circle. So I'm not going to break it up in this manner because I need to have angles that are on the unit circle when I reduce. So we know I'm not going to use that. But what I do know is I can think of 17 pi over 12. Well, let's try 13 pi over 12 isn't going to work. Let's think about this as 9 pi over 12 plus 8 pi over 12. That does give me 17. 9 pi over 12 does reduce. 3 goes into both of those is 3 pi over 4. And then plus, and then 8 over pi 4 goes into both of those twice. So it's going to be 2 pi over 3. So 17 pi over 12 can be wrote as 3 pi over 4 plus 2 pi over 3. So this is the tangent of 3 pi over 4 plus 2 pi over 3. And then I can just go ahead and use my formula. My formula is, of course, if it's a plus there, it is tangent, the plus, and then the minus between them. So let's go ahead and bring this down here. So this is going to be the tangent of 3 pi over 4 plus the tangent of 2 pi over 3 divided by 1 minus the tangent of 3 pi over 4 multiplied by the tangent of 2 pi divided by 3. 3 pi over 4, we are in quadrant number 2, which makes tangent -1 for the tangent 3 pi over 4. 2 pi over 3, when I'm in quadrant number 3, is going to give me a negative square root of 3. And then I have 1 minus, and then again, tangent of 3 pi over 4 is a -1, and the tangent of 2 pi over 3 is a negative square root of 3. And so I end up with -1 minus the square root of 3 over 1 minus the square root of 3. And I'm totally fine if you leave that answer like that. If you want to rationalize, which I don't care if you do or not, you would multiply by 1 plus the square root of 3 to rationalize the denominator. I'm just going to go through that so you can see what it looks like. In the denominator, when I rationalize it, because it's a difference of squares, I get 1 minus 3. And then in the numerator, when I distribute it through, I'm going to get a -1, and then a minus the square root of 3, and then I have a negative square root of 3, a secondary one, and then minus 3. So I'm going to get negative 4 minus 2 root 3 in the denominator. I get a negative 2. Distributing the negative 2 under each one of those two terms, I get 2 plus the square root of 3. Again, though, I want to tell you that I am actually perfectly fine if you were to give me this answer, or you can, of course, rationalize the denominator. If they're asking me to simplify the expression using appropriate identities, I look for the fact that the angles match. So I have cosine, cosine, those match, and I have the sine and the cosine 23 and the sine 23 match, the angles match. And then the cosine of 67 and the sine of 67, those angles match. And so because it's cosine, sine, I know this is the cosine of, it's going to be 23 minus 67, because if it's a plus, it's the opposite sign. So 23 minus 67 is negative 44. So this is the cosine of negative 44 degrees. These are all in degrees. Which cosine is even, so this is just the cosine of 44 degrees. And I can leave it like that, unless, of course, it says to round, but that's the exact answer. When I take a look at my next example here, I have cosine, 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 sine. Oh, all right, well, let's take a look at the cosine being even. So I know that the cosine being even, this is the same thing as the cosine of 80 degrees. Sine being odd knows that this is going to be negative sine of 20 degrees. So where I am now is this is going to be equal to the cosine of 10 degrees, the cosine of 20 degrees, minus the cosine of 80 degrees, and then the sine of 20 degrees. Now, here's the thing, though. It doesn't match the cosine, cosine, sine, sine. However, what we know is that the cosine of 80 degrees is the same thing as the sine of 90 minus 80 degrees. This is that whole cofunction thing here. Let me go down. There we go. This is that whole cofunction thing here. So this is going to be the sine of 10 degrees. So in other words, we are now at the cosine of 10 degrees, the cosine of 20 degrees, minus the sine of 10 degrees, the sine of 20 degrees. Now I have cosine, cosine, sine, which is going to be the cosine of 10 plus 20 degrees, which is the cosine of 30 degrees, which is the square root of 3 over 2. Unlike my previous example where I had the cosine of 44 degrees, I get square root of 3 over 2, and that's a nice exact answer. Let's take a look at my next example here. These 5 and 6s are radians, because I don't see a degrees there, so these are radians. Cosine, cosine, sine, sine. Oh, well, we know what that is. We just had that. That's going to be the cosine of 5 plus 6, which is going to be the cosine of 11. We're going to go ahead and leave it like that. Oh, look, we have it again. Cosine, cosine, sine, sine. So this is going to be the cosine of 3y plus y, so just the cosine of 4y, and that's as good as that one gets. Let's take a look at my next one. I see the tangent here, and it's a plus up here, so I know it is the sum of tangents. So this is going to be the tangent of pi over 9 plus pi over 6, making the same common denominator. So I'm going to multiply this by 2 and this by 3. And so I get the tangent of 5 pi over 18. And that's my final answer for that one. Boom, boom, and boom. Look at that. All right. Now they're asking us to find the exact values knowing this information. So they're giving us alpha and beta and the quadrants they lie in. So I'm going to start over here. I'm going to deal with alpha. Alpha is in quadrant 2, so Q2. And my sine of alpha is equal to 3 over 5. That tells me y is 3, r is 5, and so I'll be chasing x. So x is going to be the square root, and it's plus and minus until I know any different, of my r squared, which is 5 squared, minus my y squared, which is 3 squared. So x is equal to plus and minus 25 minus 9, which is plus and minus the square root of 16, or in other words, plus and minus 4. Because I'm in quadrant number 2, I take the minus of that. So, and again, what I'm using to find the plus and minus, and what y is in x or any of that stuff, x squared plus y squared is equal to r squared all day long. So I have found my x. That means I have found the cosine of alpha. Cosine of alpha is the x value, which is -4, over the r value, which is 5. Now I'm going to do the same thing with beta. So the beta, and beta is in quadrant number 1. So that tells me everything is positive. So I have the sine of beta is equal to 5 over 13. That tells me that y is 5, r is 13, and I'm chasing the cosine of beta, which is the x value over the r value. X squared plus y squared is equal to r squared all day long, so x is equal to, normally plus and minus, quadrant 1 means I take the plus. And I'm going to have the 13 squared minus the 5 squared. This is going to give me the square root of 169 minus 25, which is square root of 144, in other words 12. So this is going to be 12 over 13. Now, I'm finally able to do this part. The cosine of alpha plus beta is equal to the cosine of alpha, cosine of beta, minus the sine alpha, the sine beta, sine beta, sine beta. The cosine of alpha is this. So I replace this with -4/5. The cosine of beta is this. So I replace this with 12 over 13. Minus. The sine of alpha is 3/5. So I replace this with 3/5. The sine of beta is the 5/13. So I replace that with 5/13. My final answer then is going to be -48 minus 15 all over 5 times 13. Now, if your denominators do not match in this step, then you did something wrong. So the 48 minus the 15, which is the -48 minus the 15, and then the 5 times the 13. In my denominator, I get 65. So my final exact answer. So the 48 and the 15 give me 63. So I get -63 over 65. And that is my final answer. Okay. Now, I want you all to do B and C. And so I'll pause it, and then I'll let you go through it yourselves, and I'll give you the answer in just a moment. Hopefully what you got when you did the sine, let's do this in black, the sine of alpha plus beta being the sine of alpha cosine beta plus the sine beta cosine alpha. Hopefully what you have as a replacement for sine alpha is given to you as 2/3. The replacement for cosine beta is negative square root of 3 over 2. And then plus the sine of beta is given to you. So the sine of beta is given to you as -1/2. And then, of course, lastly, the cosine of beta, hopefully you all have the square root of 5 over 3. When you multiply all this together, you're going to get -2 root 3 minus root 5 all over 6 as your final answer. So you're going to do C the same way. You're going to have the tangent of alpha minus beta is going to be the tangent of alpha minus the tangent of beta over 1 plus, the tangent of alpha, the tangent of beta. Again, finding your alpha and beta as you did before. The tangent of alpha is going to be replaced with the square root, not that way, the square root, darn it, I want it red, the square root of 13 over 3, and the tangent of beta is going to be replaced with the negative square root, larger square root of 7 divided by 2, and then all divided by 1, plus the tangent of alpha, which is the square root of 13 over 3, multiplied by the negative square root of 7 over 2, 7 over 2. And then, of course, I'll just leave that for you to simplify. Cofunctions. Let's talk about cofunctions. In this one, they want us to express the function as alpha alone, and we're going to use cofunctions. If you're not sure how to use cofunctions, that's okay. You can do it by brute force. You know that the sum for cosine and sine. So sum and difference for cosine. This would have been the cosine of pi over 2, the cosine of alpha, minus the cosine of pi over 2. Excuse me, not cosine, sine, minus the sine of pi over 2, the sine of alpha. But this cosine of pi over 2 goes to 0, so that whole term goes to 0. The sine of pi over 2 goes to 1, so this just becomes negative sine alpha. Now let's take a look at B here. So again, we can brute force this by using the sum and difference. So this is the sine of alpha cosine of 180 degrees minus the sine, excuse me, sorry, the sine of 180 degrees, the cosine of alpha. We know that the sine of 180 degrees does go to 0, and the cosine of, excuse me, the cosine of 180 degrees goes to negative 1. So this ends up becoming the negative sine of alpha. So you can use the cofunctions if it's nice, easy, straightforward. If you don't, the cofunctions come from the sum and difference of angles. And we also know, if we think of this in terms of the right triangle, of course, we also get that cofunction identities with the right triangles, because with the right triangles have to add up, the two angles have to add up to 90 degrees. So 90 minus one angle gives me the sine of the other. So when I do the cosine of that. Okay. Now let's do the proving. Let's do the proving. Now, you can choose whatever side. I'm going to choose the left-hand side. Even though there is less information on the left-hand side, I'm just going to choose the left-hand side because I know that the pi over 4, the tangent of pi over 4 is 1. So I'm choosing, in this case, the left-hand side. So as before, I rewrite that left-hand side, so x plus pi over 4. Now I'm going to start using the sum and difference for tangent. So that's going to be the tangent of x plus the tangent of pi over 4 divided by 1 minus the tangent of pi over 4, the tangent of x. But we know the tangent of pi over 4 goes to 1, so this is simply just going to be the tangent of x plus 1 over 1 minus the tangent of x, and we get the right-hand side. Now let's take a look at the next example. I'm going to take the left-hand side because I think it's going to be easier to expand out the tangent, the sum and difference for tangent, than it is to try to go backwards. If you feel the other was easier, by all means, please go the other way. So I'm gonna take the left-hand side again, left-hand side, and I rewrite the tangent of a plus b over the tangent of a minus b. Numerator. This is the same thing as the sine of a plus b over the cosine of a plus b. Denominator, this is the same thing as the sine of a minus b over the cosine of a minus b. So let's go ahead and expand out the numerator. The numerator is going to be the sine of a, the cosine of b, plus the sine of b cosine of a, over the cosine of a, the cosine of b, minus the sine of a, the sine of b, divided by, now the denominator is going to expand out into the sine of a, the cosine of b, minus the sine of b, the cosine of a, over the cosine of a, cosine of b, plus the sine of a, the sine of b. Now what I have is a fraction, that's the black one, over another fraction, that is the blue one, so I have a complex fraction, a fraction over a fraction. My lowest common denominator is going to be this denominator right here, multiplied by this denominator right here. So let's go ahead and multiply the numerator and denominator by that. So when I multiply the numerator and the denominator, so I'm going to do this. Let me just erase this so it doesn't muddy out the waters. Okay. So I'm going to go ahead and multiply the numerator by the cosine of A, cosine of B, minus the sine A, the sine B, and it's also going to be multiplied by the denominator of the second fraction in the denominator, which is the cosine of A, cosine of B, plus the sine A, the sine B. Do the same thing down here. I'm going to multiply it by the cosine of A, the cosine of B, minus the sine A, the sine B, cosine of A, cosine of B, plus the sine A, sine B. The sine of A, the sine of B. Now, what's going to happen is that when I do this multiplication, this one will cancel with this one. In my numerator, I'm going to be left with the sine A, cosine B, plus the sine B, cosine A, multiplied by the remaining part, which is the cosine A, the cosine B, plus the sine A, the sine B. Sine A, yeah, sine B. Okay, cool. In the denominator, I'm going to have the sine of A, cosine of B, minus the sine B, cosine of A, multiplied by, this one will cancel with this one. So it's going to be multiplied by the cosine of A minus, the cosine of B, cosine, not what that was, not cob either, the cosine of B, minus the sine of A, the sine of B. Now what I'm going to do is I'm going to distribute this out, and when I distribute these two, I'm going to get sine of A, cosine of A, the cosine squared of B. So that's just those two. Now I'm going to multiply these two, which is going to give me plus the sine of A squared, the cosine, or actually I'll do the sine next. I'll do the sine of B, and then the cosine of B. I'm going to distribute and do these two, and then I'm going to get plus the sine of B, and it'll be cosine squared of A, and then the cosine of B. I'm going to do these last two, and this is just the numerator multiplying it out. So I'm going to get the cosine of B, so it'll be this plus the sine squared of B, because of the sine squared of B, and then the sine of A, and then the cosine of A. Whew, that's all of the numerator. Let me do this. I'm going to do the same thing. I'm going to distribute out the denominator. So I'm going to do this multiplication first. And it's going to be the sine of A, the cosine of A, the cosine squared of B, minus, and it's going to give me something similar in the denominator. It's going to be minus the sine of A squared. Not A is squared, but the sine squared. So let me change that. It should be sine squared A, not A squared. Sine squared A. And then I'm going to have the sine of B and multiplied by the cosine of B. And then minus will be the sine of B, and it'll be cosine squared of A, and then cosine of B, and then minus is plus, and it's going to be sine squared. So it'll be sine squared of B, sine of A, cosine of A. So that is that multiplied out. Now, I'm going to look to see if I got any like terms, and I don't have any like terms. So what I'm going to do is I'm going to replace the cosine squared, wherever I see cosine squared, which is right here, this cosine squared, the cosine squared of B, is equal to 1 minus the sine squared of b. So every time I see that, I'm going to do that replacement. And then wherever I see the cosine squared of a, I will replace that with 1 minus the sine squared of a and see where I am. So that's also right here. So I have the sine of a, cosine of a, 1 minus the sine squared of b, plus the sine squared of a, the sine b, the cosine b. And I probably should take care of my squared a as well. Yeah, I think I'll do that too. So I'm going to erase this, and wherever I see, which is right here, the sine squared of a, and we replace it with 1 minus the cosine squared of a. Nah, I'll just do it on the 1. Okay. Yeah. So I'm going to get the sine squared of a, the sine of b, cosine b, plus the sine of b, cosine b, and then 1 minus the sine squared of a, and then plus the sine squared of b, the sine of a, the cosine of a. Now, that's just the numerator. All right. Now, let's just work with the numerator, because it's going to be something similar to the denominator. I'm going to go ahead and distribute this through. So I'm going to get the sine of a, the cosine of a, minus the sine squared of b, the sine of a, the cosine of a. That is just this part. And then plus the sine squared of a, the sine of b, the cosine of b. That is just that part. Didn't do anything to it. I'm going to distribute on the next one. So I'm going to have plus the sine b, cosine b, and then minus the sine squared of a, the sine b, the cosine b. That is this multiplying through. So that is this part right here. And this is this part. And remember, I'm just working with a numerator for the moment, because I'm going to get something similar in the denominator. And then lastly, I'm going to do this last expanding. So actually, I'm just going to rewrite this. I have nothing to expand. So the sine squared of b, the sine of a, cosine of a. And that is just rewriting that last piece. Now, I now have a sine squared b, sine a, cosine a. So I see it looking for a sine squared b, sine a, cosine a. Oh, look. This will cancel out this very last term. I also have the sine squared a, sine b, cosine b. This will cancel this term out. So what I'm left with is only this term and only this term in the numerator. Let me expand out. You can see that's all I'm left with because everything else cancels out. So my numerator is going to give me the sine of a, the cosine of a, plus the sine of b, the cosine of b. Now, if I do something similar to this like I did with the denominator, and I replace the cosine squared of b with 1 minus the sine squared of b, and the cosine squared of a with 1 minus the sine squared of a, I will get the exact same thing, but with a minus between them. Sine of a, cosine of a, minus the sine of b, cosine of b. So I ended up with a whole bunch of work, but I did get there in the end, and I got the right-hand side. So the thing that you want to take away, the takeaway on this one is this part right here. This is really important. You'll see this a lot. This is something you will see a lot in replacements to get everything in terms of one or the other. Okay, now I just want to go back and look at these other ones. Now, C is going to be pretty straightforward. I'll take the right-hand side this time. It doesn't really matter, right hand or left hand. Left hand will be easier, but I'll do the right hand. 1 minus the tangent of A, the tangent of B. This is going to be equal to 1 minus the tangent is going to be returned in terms of sine and cosine, which is the sine of A, cosine of B, and then multiplied by the sine of B, the cosine of A, if I multiply the 1 over 1 by the denominator of cosine A cosine B, then this is going to be the cosine A cosine B minus the sine A sine B all over the cosine A, the cosine B. And all I did there was I multiplied this 1 by the denominator so I can add the two fractions. We know the numerator does combine into the cosine of A plus B, and then the denominator is going to be the cosine of A cosine of B, and I found the left-hand side. I think this one would have been easier to expand this out and then put this underneath each one of the terms. So here we are, if we go backwards, if I would have chose the left-hand side, this would have been my first step, and then I would have put the cosine of A cosine B underneath each one of those two terms, and I would have gotten the other side. 6 1/2 dozen of another. Now, for this one, left or right, it's about the same amount of work. If you decide that you want to go with the left side, cool. If you want to go with the right side, cool. It doesn't really matter in terms of the amount of work done. If you choose the left-hand side, then you're going to do the left-hand side. You're going to get the sine of alpha plus beta, the sine of alpha minus beta, and then you're going to expand them out. So you're going to get the sine alpha cosine beta plus the sine beta cosine alpha. And then you're going to do the sine alpha, the cosine beta minus the sine beta, that was terrible, beta cosine alpha. If you go this way, totally cool. You're going to divide both the numerator and denominator by the same thing, and what you're going to divide by is this, because we need to have a 1 there. Pretty straightforward, just a couple of steps. If you chose to go with the right-hand side, it's still not too bad. 1 plus the cotangent alpha, the tangent of beta, 1 minus the cotangent alpha, the tangent of beta. Because you want to turn it in terms of sine, then your first step is to rewrite the cotangent and tangent in terms of sine and cosine. So we have the cosine alpha, the sine beta, and then the sine, and they're both sine alpha. And then this is going to be the sine beta over the cosine beta over 1 minus, and then it'll be the cosine alpha, the sine alpha, and then it'll be the sine beta, and then the cosine beta. Now, if you go this path, and what you're going to do is you're going to multiply the numerator and the denominator by this value, the sine alpha, sine beta, and then you can then just reverse. 6 1/2 dozen of another. I think this one is easy either way in terms of the steps like we did on C. C is a lot more work than, actually not C, excuse me, B is the most work. Notice at B we had to do lots of steps. D and C are pretty straightforward. You should be able to do it within like 2 or 3 steps. B as in boy was a lot more work. You can see B as in boy is right there. So anyways, that's it for this section.